Good morning, people of the internet and people of the future. Welcome to the Salem State University Collins Observatory's live stream of the partial solar eclipse from near Boston, Massachusetts on June 10th, 2021. If all is going according to plan, you are seeing the live feed from our 12-inch refractor telescope hooked up to an infinity color CCD video camera, and hopefully you're seeing the limb of the sun here. It's cloudy around here in Boston this morning, so you can't see the eclipse with your eyes, but that's just as well, because you should not look at the eclipse with your eyes. It is not safe to do so. But it is safe to look at a live stream on the internet. And so hopefully that's what you're doing instead. Let me adjust the camera a little bit here. So this is partially a test of our equipment for live streaming solar events. It's not safe to look at the sun through a telescope either, unless you have a special solar filter, which we do have set up. It covers the aperture of the telescope. The hole that lets the light in has to go through this solar filter, which cuts down most of the light that's coming in. And you can see this bright triangle looking thing here is the sun, and it would be a circle, but something's cutting into it, and that is the moon. And that's why it is a solar eclipse. So my apologies for the settings. Just trying out the equipment this morning, so this is new territory for us. Try and find a good setting. And with the CCD camera set up, we can't change how zoomed in we are, because to do that you need an eyepiece, and we're putting the camera instead of where the eyepiece goes. So we don't have any control over how zoomed in we are, but do have control over how much light we're letting in with each frame of the video. And so I'll mess with that in a minute, but just give you a little tour of the shape of what we're looking at here. Over here is the moon, and this is the sun. It was looking a little better right before I started the live stream, so I'll try adjusting these settings again. Ooh, that's interesting. It's on auto adjust, so it will change as I have more light going in. But I'll try and show you that as we go to the other side of the sun. We should see the other horn of the what looks like bull's horns right now during the solar eclipse, because it's not a total solar eclipse, it's a partial solar eclipse. While I'm giving you a tour of the other side of the sun here, I'll tell you a little bit about eclipses, and hopefully you're also looking at a view of the sun and the moon intersecting on the yeah, there we go, on Stellarium Web, which is a free web application website where you can go and search the skies for what's going on now or in the future or in the past. And I have it set up to be a live view of the moon and the sun as they intersect. So that's the bigger picture here. Now I'll try and show you the zoomed in picture as well from the live telescope view. pointing the telescope while it's hooked into a camera is also a bit of an art because I can't use the finder scope, it would burn out my eyes. There's the other horn of the bull's horn. That's how the sun appears right now, because right here is the moon and here is the sun, and they are overlapping. A little bit about solar eclipses. One of my mentors always said it's the most amazing example of serendipity in the universe you can think of, that the sun and the moon look the same size in the sky to us. They're each half a degree on the sky in apparent diameter. And there's no reason for it. It's just a coincidence, but they happen to exactly match up in their size, just about. They're both half a degree, and so that we can have total solar eclipses and we can have total lunar eclipses. There's not many places in the solar system that you can have both of those kinds of eclipses. And moreover, we can have a perfectly lined up total solar eclipse where the moon exactly covers the sun, because the sun is, although it's not 400 times bigger in diameter than the moon, it's also 400 times farther away, and it just happens to be lined up so that the sun being bigger would tend to make it look bigger in our sky, but it's so far away, which tends to make it look smaller in our sky, and those two things counteract each other exactly. So we can have perfectly lined up total solar eclipses. However, the orbits of the moon around the Earth and the orbit of the Earth around the sun, they're not perfectly circular. They're slightly elliptical. So sometimes the moon is a little closer to the Earth and sometimes a little further away. And sometimes the sun is a little closer to the Earth and sometimes a little further away. And so they'll change a little bit in apparent size in our sky, such that sometimes the moon's a little smaller than the sun and it can't completely cover it. And that's what's going on in this partial solar eclipse. The moon is near apogee, which is its furthest point from Earth as it goes around in a slightly elliptical orbit. So it's a little smaller in our sky than the sun is right now, and so no matter where you are on Earth, you're not seeing a total solar eclipse. There is some real estate where you could be viewing an annular eclipse. That's where the moon is completely in front of the sun, but it doesn't quite cover it, and so it looks like a ring. And that's why it's called an annular solar eclipse. I believe it's Latin for ring, something like that. I never took Latin. Let me see if I can adjust these settings here. I'd love to be able to see a sunspot. But I think we're already pushing the camera to its maximum. Let's see, can I go any smaller? I wonder if I can stack these images. Okay, let me try recording. So if you have any questions, you could put them in the comments section of YouTube, and I won't get to them right now, but I will go back and check them out and answer your questions the best I can. Alright, the stacking doesn't seem to be all that helpful. You can already see the triangle shape is changing here. It's getting to be a wider triangle. It's looking less and less like bull's horns, and that's because we're we're past the point of maximum eclipse. And so the sun is going to be less and less covered as we go forward. The maximum solar eclipse was somewhere around 5:30 a.m. And it is now just about 6 o'clock by my calculations. And the sky is cloudy, like I said, and so we can see some clouds passing by. But the telescope lets in so much light from the sun, even with the solar filter, that it can cut through the clouds a lot better. We're capturing that light better than you would be able to, even using solar protective glasses. So you're getting a better view here than you would be if you're trying to observe it on your own. But like I said, we can't zoom out, unfortunately, and see the whole picture with the telescope. That's why I have this broader perspective here on Stellarium Web, so you can check that out. But you can see the moon is covering less and less of the sun as we go forward. Alright, let me try and auto range. Let's see if that helps. Try Binny. That did not seem to help. Oh well. Trying to see any evidence of sunspot. I do see some spots, but I suspect those are dirt on the solar filter, because when I move the telescope, they also seem to move in relation to the edge of the sun here. So yeah, I don't think those are sunspots. I think those are just dirt spots. Well, since I can't really adjust anything, I'll go at full screen mode, and then we can just check it out that way. And we can see the shape of the sun changing moment by moment as this moon overlaps with it less and less. Of course, we had the great American eclipse back in 2017, where there was a path of totality that went right across the continental United States. And I hope you got a glimpse of that. We had a really nice view from Boston area, and we weren't in the path of totality, but it was a great eclipse nonetheless. And we have another one coming up in a little over a couple of years, 2024. The next one's going to come across the continental US, traveling from south to north up through Burlington, Vermont, among other places. So keep an eye out for that. I'm going to try adjusting the focus of our telescope here, see if I can sharpen up those edges. Oh, we've gone Technicolor. hoping that if I get the right focus, I'll see a sunspot. Edge seems to be getting sharper. That's a good sign. Now it seems to be getting less sharp again, so I guess that's about as good a focus as we're gonna get. Alright, I'll leave it there. See, this triangle shape is getting less and less triangular, and it's getting to be more and more closer to a 90-degree angle over here. It shows you that the moon is moving off. Oh, let's see here. Check the solar weather today. So the sun has weather as well, and some of the more interesting weather events are sunspots. And today's sun, you can see there are two sunspot groups. This is the the most recent observation, I believe, and there's one sunspot group down here and another down there. So I'm not 100% sure which part of the sun we are viewing, so whether the sunspots are in view to us or not. I'm not 100% sure, which is why I'm trying to move around a little bit so we can try and catch them. The sunspots are caused by magnetic activity on the sun, and it's a really fascinating mechanism by which they happen. So the sunspots are spots that look dark, and that's because they are slightly cooler than their surroundings, and so they emit less light than their surroundings, so they look dark to us. Even though they're still pretty hot, about 4,000 degrees Kelvin instead of 5,000 degrees Kelvin. The rest of the sun is around a little over 5,000 degrees Kelvin. Sunspots are a little less than that, about 4,000. And so they look dark to us because they're giving less light out than their surroundings. Why are they a little cooler? That's because they are spots where the magnetic field of the sun has been twisted up so much that it pokes in and out of the visible part of the sun and pushes out material so that it's not as hot there. And there is a connection between solar activity in terms of how many sunspots are present on any given day and the temperature fluctuations on Earth. And we have hundreds of years of sunspot observation data. And we have even more of that has more years of Earth's temperature data. And so we can see that there is a connection overall between them. But that connection is certainly not enough to explain the most recent temperature rise on Earth. So something else is going on. And the bumper sticker version is humans. Okay, so I don't see any sunspots, but we can definitely see this triangle is becoming less and less triangle-y as the moon moves off the sun. Let me see if I can swing the telescope over to the other side of the sun so we can get more of a perspective of what we're looking at. Again, this is the sun down here. The camera is adjusting its colors automatically. I don't have any control over that at the moment. And the moon is the thing that's preventing the sun from being a complete circle. Let me move the telescope. I'm moving the telescope over the other way to try and get a view of the other horn. So right now this is the moon over here, this dark shadow, and we are looking at the dark side of the moon. That's the moon, part of the moon that's not illuminated by the sun. It's often said that we only see one side of the moon, and that is true. It's also said that there's always a dark side of the moon that is not illuminated by the sun, and that is also true. People get those two things confused, however. Usually they are not the same side. There's always a side of the moon that is dark because it's facing away from the sun. But that is usually not the far side, the side that is facing away from the Earth. Today, the dark side of the moon is the near side facing the Earth. So the near side is the dark side right now during solar eclipse and during a new moon in general. Okay, so this is the other side. We can see this is turning into pretty much 90-degree angle as well. It's no longer looking so much like a pair of bull's horns. It's getting more and more of the sun visible. Okay. I'll take another quick look at stellarium. Okay, we can see the eclipse is almost over. The moon is almost moved past it. And we can use this software to project forwards into time to see when the moon will be completely off. So I'm going to switch away from real time for a second to jump forward in time. We can see as the sun and the moon. Whoop. March forward into time. We're time traveling. The eclipse will be over at 6:30, essentially. There's no, at 6:30 the moon and the sun will be completely not overlapping anymore. So right around 6:30 is when the eclipse ends. That's when the last piece of the moon will be covering the sun. I'll jump back to real time and I'll try and find the moon again. Let's see where to go. Folks, I apologize. I may have lost the sun and the moon. I know it's important to everybody. Oh, there they are. Got them back. Okay. So here's the moon in the sun's current view. I'm going to zoom way out so you get some more perspective of what that's like in our sky. There's Mercury, the planet Mercury. And here's a generic view of the horizon. Here's due east. And since we're in the near summertime, the sun rises north of due east. On the equinox, it rises due east, and in the winter months, it rises to the south. Let me try and zoom out a little more so you can see north and south too. There's north, and there's south over there. And I can also put in here a line that shows you the general path of the sun through our sky, called the ecliptic. So it rose over here and is traveling up and across the southern sky. Okay, but right now it's a little north of due east, and I'm going to zoom back in so you can see that amount of coverage, current coverage. You can see the sun and the moon are pretty much near the same path. And in fact, everything in the solar system, including all the planets like Mercury, which is right over here, and Saturn and Jupiter, which are over on the other part of the sky. I think they are still up. Yeah, here's Jupiter, here's Saturn. They all travel near this path called the ecliptic. And that's because all of our solar system objects are in the same plane, going around in elliptical orbits. And the moon is also pretty close to the ecliptic in general. It will be sometimes 5 degrees above, sometimes 5 degrees below, but overall it stays pretty close to the ecliptic. And that's why that's why it's called the ecliptic, because that's the path along which all the eclipses happen. In order to have an eclipse, you have to have an overlap between the objects. Sometimes they're too far away to overlap, sometimes they're close enough. Right now we have close enough for a partial eclipse because the moon does cover the sun from some vantage points on Earth, or at least it gets in front of it, but it's right now so far away in its journey that it's a little smaller than the sun, so it can't completely cover it during this eclipse. But in summer 2024, it'll be a different story. We'll have another total solar eclipse in the United States. Alright folks, I think that is gonna do it for this live broadcast of the partial solar eclipse from Salem State University's Collins Observatory. Thanks for tuning in. I hope you found this interesting and informative. And if you do have any questions or comments, you can leave them in the comment section of the YouTube video and I will reply. Thanks so much everybody for tuning in. I am going to sign off and stay tuned for more events from the Collins Observatory. At least one more this summer. We'll try and check out some planets a little later in the summer. But in the meantime, keep looking up.